Regardless of the dimension and complexity of the original products, it should now be clear how the isolation of the core composite parts from other components is a crucial step to enable the targeted recycling and recovery of these materials. In the last video, we understood how this general concept is declined for large composite infrastructures. This video instead focuses on smaller composite components assembled in complex products. Road vehicles are probably the best example of how several composite parts with different characteristics and functionalities can be merged into the same product. In traditional combustion engine vehicles, it's easy to find injection-molded glass fiber thermoplastic parts. The covers of the clutch, the gearbox, the engine, and other components are often made of composites. Polymers such as polyamide are usually used, with a glass fiber percentage ranging from 10% to 30%. These pieces are often labeled with simple codes describing the constituent materials. For example, this label identifies a piece made of PA6 polyamide with 15% glass fiber content. In modern and sporty vehicles, composites are also used to manufacture structural components for lightweight and mechanical performance. Parts like the passenger cell, the chassis, the outer body, the wheel rims, the spoilers, can be made of glass or carbon composites. Identification codes labeling is not usually done for these components. Road vehicles are a relevant example of the difficulties characterizing the sorting of composite components from complex assemblies. Small and mid-sized parts are embedded in bigger structures, often irreversibly joined by rivets and glues. Their isolation is therefore a manual and time-consuming task. Operators must be trained in the identification of composite parts, and dedicated collection containers must be arranged. This negatively affects the economic sustainability of their dedicated recovery. Nowadays, this best practice is actually never made for composites in car dismantling centers. On top of that, these parts are often contaminated by oil and powder, and they don't always have a label which categorizes their resin and fiber type. To conclude, the sorting of composite components from complex assemblies is even more challenging than the dismantling of large fiber-reinforced polymer infrastructures, and theoretically more important as well for a large-scale adoption of dedicated recycling and reuse process chains.